In example 1, we need to add these two vectors together, and we're going to do this geometrically. There definitely is an algebraic way to do this, but we're going to try to do this algebraically. The method that I'm going to use, or excuse me, geometrically. So the method I'm going to use for this is called the parallelogram method. And you'll see why it's named that way here soon. There's another method I'll do in the next example that's called the tip-to-tail method. But for now, we're just going to use the parallelogram method. If you don't have one right now, try to get a protractor, and also try to get a ruler. You'll need those two things. We're going to actually look at vector W, which is 100 degrees and 5 centimeters. We're going to represent that here on the coordinate plane as being exactly that. So we're going to start off with doing vector W. What you need to do first is get the degree measure down. And when we start this here in standard position, remember the standard position of an angle is going to be with the initial point here at the origin, and the initial side is on the positive x-axis. And so we can make a little mark, maybe out here, and that's going to be 100 degrees. Keep in mind that we're bigger than 90. We need to go to 100 degrees over here. And to make our vector, you can either do this at the same time or a different time. And what I'm going to do is I'm just going to draw a line across here for now and just do it nice and light and easy. And then I'll bold this in for you. And we want to make sure that this is at 5 centimeters. So if I switch over to the centimeter scale on my ruler here and get as close as I can, it looks like that's going to stop right about here. So I'm going to draw this for you, and if you do this with a ruler, it's all the better, but it tends to smudge a little bit with the Sharpie, so we're just going to do this. So the distance here is 5 centimeters, that's the magnitude, and then 100 degrees is the direction. For the parallelogram method, we're going to start at the origin again, or at least draw another vector that is in standard position. So try that in orange, maybe that'll stand out a little bit. But before we do that, let me make sure that I've got this guy down. And so we need to do 30 degrees, and then if we just mark that on our protractor here, that's going to be right about here. And we can draw ourselves a little guideline and then measure out, and this time it's going to be just 3 centimeters, so this is going to be vector Z. And let's see here, there it is, right about there. And you can draw that guy right here in this direction. Okay, so this is vector Z. Remember, we indicate a vector by utilizing the little half barb on the end, and this will be a vector W right here. So you might have guessed it already, but the parallelogram method, it uses a parallelogram. So all we need to really do is to produce a parallelogram. And if you remember for your with your geometry work, that when we produce this parallelogram here, and again I'll try to do this with a pencil and just darken it in with the Sharpie here. But we need to make sure that not only are the sides parallel, but opposite sides, but opposite sides are also congruent. So we measured this one at 5 centimeters, and we're going to do the exact same thing here. So we'll make a little mark there, and then we need a brown marker here. So the parallelogram method, we're just starting to kind of make a little parallelogram here. Now if we've done this correctly, hopefully the other side should be parallel as well, and it does look parallel, and then it should be the same distance, and we do have 3 here. Now if we just took this guy and moved it, it would look something like this. And the secret to this is the resultant vector, which is what happens when you add, subtract, or multiply, perform some operations on a vector. That will be this one right here. We're going to go from, see where the tails are together, and then we're going to go where the heads are together up here, where the arrowheads are. And so the resultant vector will be this one right here. The one in green. So the one in green, maybe we'll name that, I don't know, x or something like that. And so that's the resultant vector. So we have to do a few things. One thing that we need to do, and I'm going to extend this line just a little bit. One thing that we need to do is we need to figure out its magnitude, and also to figure out the degree for this one. So if we take a look at our handy dandy protractor here, it looks like this is about 75 degrees, maybe 74. We're going to call it 74. So we'll do our resultant vector here is 74 degrees. And then the length on this, we'll get our ruler out again. And if you're using centimeters, you'd want to use those as well. So it looks like we've got about 6.5 centimeters there. So we could say that our resultant vector x here is 74 degrees and 6.5 centimeters.